Okay, so you've completed, or you want to complete that. Yeah. If you haven't already checked it with your neighbors, I'm assuming you have. You've been talking. So let's just go through and discuss a few things here. First, it's up to you how you went through and done this. I'm going to try to go through a little quicker way, or the way I think is the quickest. So if you look at this and put all these as y, or put y on your left, so you have y is less than or greater than, you'll notice that your y-intercept, you have -2, -2, -2, -3, +3. It becomes a situation where, in the -5, you can kind of rule out some of these or match some of them up. And there's only one with a y-intercept of -5. So if we find that graph, that's this one right down here. Okay, letter C goes with equation 2. You also could look at the symbol. This is saying my y values are greater than this function. Okay, so from the y-intercept, I am going to shade above. I'm going to shade up. All right, if I take a look at the ones where you have a 3, a +3, there's only one of those. So find the y-intercept of +3. Okay, it is saying that my y values are greater than +3. So if I find +3 on the y-axis, I'm shading all the y values bigger than those. Okay, if I take a look at the ones that have -3, well, there's only one of them, so I go to -3. This is saying my y values are bigger than all the y values that are at -3. Okay, so we're shading up here. And then if I take a look at the ones that have the -2, there are 3 of them. 2 of them are dashed, 1 is solid. Okay, so I can look at for the solid one, and that tells me number 4 goes with E. Didn't even have to solve it. I could look at it and say my y values are less than -2. So I'm at -2, and I'm shading all the values below -2 on the y-axis. And then the 2 that both have -2, and they're both dashed. Okay, you could look at width. This one's thinner than this one. You could just say, well, that's probably the best way of doing it. Okay, you look at the width. This one, we're at -2, and this guy here, we're at -2. This one's thinner. This is my -5. Okay, and this one's my -3. All right, notice you go over 1 and down 5 to get to your next point. Here you go over 1 and down 3 to get to your next point. All right, notice they're both less than, so my y values are less than -2 on both of those. So I'm shading all the y values smaller than -2, which brings me down the y-axis like that. Okay, now those of you testing points, it's okay to do that as well. I'm just trying to show you, look, if you have it in y form on your left, a y greater than or equal to, you shade the greater values, or you shade up the y-axis. Y is less than or equal to, you shade down the y-axis. Okay? All right. Questions? All right, very good. I want you to take a look at yesterday's assignment. I asked you to complete problems 13 through 15 in your student journal on page 74. So looking at those there, we actually did number 13 together. Okay? But go ahead and compare your work for 14 and 15 with your groupies real quick. And then we'll talk about 16. Attention back up here. I'm going to put up the answers for number 14. You can kind of check that one out. Now, you'll notice some scratch work here. This, if you change to decimal form, was about 2.76. Or 2. I think that's 6. I think that's an 8, yeah. 2.78 and 12.17. Let's just call that 12.22. Okay. If you left it as radical, that's okay. Please note that the way I wrote it here, my y would actually be on this side. So if you want to kind of go with the same thing we had earlier, you would have to say, well, if I were to think of it as y is greater than or equal to x squared minus 15x plus 34. And think of it like that. That means I would be shading all the greater values. I'd be shading up the y-axis. Okay. And since this parabola opens upward, that would mean that I'm shading in between the branches of the parabola. Right? Everyone good on that? You understand what I'm saying? If your parabola opens up, you're going to be shading in between the branches if it's an and graph. Okay? So, if this case right here, I went through and I flipped it around. I have my x equals. I did not keep the inequality symbol until I got to the very end. And notice, the very end, I have my x on the left. Therefore, if I'm just looking at the positive solution, my symbol carries down with the positive solution. And then when I do my negative case, I've got to flip the symbol around, or not my negative case, but when I have my minus, so we have the plus minus, when I have the minus part, I've got to flip the symbol around. So you could think of it as two different answers. You have x is greater than 15 minus root 89 over 2, and then you have x is less than 15 plus root 89 over 2. Okay. Questions on that one? How many got that one? Okay. How many know where they made their mistake if they didn't get it? Okay. Number 15. 15 is a little more complex. It was kind of an ugly problem. Okay. And in fact, so ugly that we found a mistake in my last class. I had 225. It should be 125. So if you check this earlier, there'd been 125 there, which makes this 125, which makes this 750. Okay. Anyway, you break it down. That is 25 plus root 750 and 25 minus root 750. Okay. When you do the minus one, notice your sign flipped over. Okay. Makes this is root 30 here. If you round it, it's 52.4 and 2.4. Okay. So once again, at the very beginning, if you were to write this in y equals form, or the y format here, okay, I would have, well, actually, should do it down here. So I'm going to run out of room there. I'll rewrite it on a separate sheet here. Let you take a look at that.
It should be positive 52.4 and negative 2.4.
Is that positive 52.4? Are they?
Yeah.
Oh, I got that. I got that from my last period, so I'm going to blame them. Hold on. So this value right here, 25 minus, let's see, that's 5. Okay. What is that?
It's about 27.4. The 5 and 30.
Oh, okay. So this gives you the negative 2.4 here.
Yeah.
Okay. And this is 52.4-ish there.
Yeah.
Okay. Why does that say 1? That other piece didn't erase. All right. Thank you. Okay. How many got that one? All right. How many know where you made your mistake? Got lost? Okay. What are the questions we have? No questions. All right. Check out number 16 real quick. See how you did. Question?
For the 113.49, I plugged it in to check, and it was like just under, so is it okay if it is 13.50?
Yeah, technically this would round up to 1350. If you think of it in context of a problem, you wouldn't want a partially eaten hot dog. Okay. I'm just saying. Is it 51? I didn't. Oh yeah. Well, no, because then that's on the upper end, right? So you'd want to be less than 50. You don't want it less than 51, otherwise you're going to get that partially eaten hot dog again. So here we would want to round, we go to 50 because we don't want a partially eaten dog. And here we'd round to the 50 because we don't want a partially eaten dog. Okay? All right. Any questions there? Yeah, I thought Walsh had a good question in my last class, so I'm gonna bring that question up. Hey, you can have good questions. Okay. He really, what was happening, I think, with his question, he was thinking of it in a linear thought process, which I think is something that a lot of people do. But let me put this on the graphing calculator real quick. I'm not going to get rid of that other one because I might want it later. But let's see, 140x is 152,500. You got all that right? Okay. Hit graph. Here's my parabola, and yeah, it's zoomed in quite a bit there. But if I'm gonna go to zoom fit. Okay, we're gonna go to zoom fit, which sometimes takes a while, and then I'm going to go to zoom out, so hopefully I can actually see what I'm trying to see here. It probably would have helped if I would have went zoom standard first, but that's okay. Just spit on this. All right. Not much happening there. Let's go zoom box. I'm really trying to see these intercepts here. And that didn't help. That is ridiculous. No, did I mess up on my function? That is correctamundo. Zoom 6. Zoom fit. Yeah, I know. Zoom out. All right, ridiculous. I'll come back to that here in a minute. I do want to point something out because I thought it was a very good point, but I deleted my function. But that's okay. We'll come back to it. While we're waiting for me to come back to that, I'm going to have you guys start this problem. Okay? Good, helpful thought process would be to write down the formula for area and perimeter. Okay, so perimeter. What's the formula for perimeter of a rectangle? Good. You have length, you have width, you have width. So perimeter is equal to 2L's plus 2W's. Okay? What's area? L times W. Okay, so now they tell us some stuff. They tell us that the perimeter is 440. Okay? They also tell us that the area has to be at least 8,000. That means our equal sign is no longer equal. It is greater than or equal to. Good. Now, we have a system here. It says to describe the possible lengths. We have a system of equations, and both those equations have L and W in them. We want to solve for which one? L, possible lengths. So, first thing, I want you to talk with your group and figure out which one would be, or what's the best way to go about solving that. Okay? I don't want to give you too many. All right, here we go. It's shouted about that our inequality symbol was incorrect here. That is very true. We have to have 8,000. Okay, the area has to be at least 8,000, meaning the area, which is represented by this side, could be greater than. Okay? All right. So, what do? Haley. Okay, divided by 2, same thing as multiplying by 1/2. Yeah? What's it give us? Good job. All right? How does that help? Someone else. Okay, it does get rid of some coefficients there, so we just have the variables. What else does it do? Yeah?
We can have them connect with the other one. With the 8,000 is less than or equal to 1 times W.
Okay. So we have a system. How are we going to solve it? Elimination, substitution, graphing. What do we do? Emma? Okay, hold on 1 second. Let me pause you right there. So we have all this. W, we solved that one for W, and we plug it in here. And that's where we will pick up with what Emma was continuing. Okay, now from there, someone else tell me what we can do with that. All right, actually, you guys figure it out with your group real quick. Hey, what did we do? Yeah, just distribute. All right, now what do we do? Good. So I'm going to rearrange this stuff. So now I have a quadratic over there. And so from that point, we can actually do the quadratic formula. Or you can try factoring. You do a bunch of different things. Yep, you could do, if you left it on this form, you could do completing the square. Okay? All right, let's go ahead and solve for L. All right, those are my values for L. Okay, now how many did the quadratic formula? Okay, how many got 45.96, 174.03? Okay, so if you left them in radical form, go ahead and change them out. Okay, if you're thinking of a graph of this, think how your parabola would actually do something like this here. This point right there would be your 45.96. This point right here, your 174.03. All right, and so you got, how many of you remember graphing inequalities just on a number line? If I was just to graph this thing on a number line, I would have a straight line that would intersect at 174.03 and then intersect at 45.96, and this one would shade that direction, and from this point I'd be shading this direction, so it'd have the shading in between. Well, that's all that's happening here. Shading's in between. When it's in between, that means I'm looking at this area here. Now, what's important about this is that our graph can't exist down here in the negative quadrant, right? It's up here. All right? It's where our area is positive. So our lengths are in between 45.96 and 174.03. Okay? That is our solution. All right. Questions? This, by the way, is negative 8,000. Tell your neighbor how you know that. Y-intercept. All righty. Okay, hey guys, just so we can go back to that one problem, not that everyone is totally into it again, but there's our hot dog problem. I don't know what was going on with my graph, but there it is. And so just so you're aware, this right here, this 0, is your, oops, right there is your 1350. This is your 5650 right there. Okay, and so the part up here, that's where your profit is. If you sell more hot dogs than that, maybe you're buying too many supplies or something, your expenses are outweighing your profit. And over here, you're not making enough profit either. So just where it's above the x-axis, this is profit land. This is not profit land down there. Okay, so if you're looking at it in terms of your your graph, you're wanting quadrant 1 there. Okay? Was that the problem?